Hello. In this video tutorial, we're going to be looking at skills practice 15.2, Coulomb's law. Remember to pause or rewind the video as necessary. Please read along with me. In this skill sheet, you will work with Coulomb's law. There are many similarities and differences between the equation for universal gravitation and the equation for Coulomb's law. They are both inverse square relationships, and they both have similar arrangement of variables. Universal gravitation had an equation that looked like gravitational force was equal to a gravitational constant times mass 1 times mass 2 divided by the square of the distance between the masses. So you can see we were focused on mass, and distance. Well, Coulomb's law deals with electric force, but it's a similar idea. F, the electric force between two charges, is equal to K, which is a charge constant, times Q1 times Q2, divided by R squared. So you'll notice instead of two masses, we have two charges separated by a distance. Okay, so if we focus on the actual equation we're going to be using, you'll see that the equation is K, which is this number here, 9 times 10 to the 9, times Q1 times Q2 divided by R squared, where R represents the distance between those two charges. Now, if you're not given actual charges or distances, but you're given how much the charge or distance increases or decreases, then you would use a proportional reasoning version of the equation. You would use a Coulomb's law proportion. So this is the Coulomb's law equation. The Coulomb's law proportion has force directly proportional to charge 1 times charge 2 divided by R squared. You'll notice the only difference is you just don't include the K, and you put in the changes in the variables, not actual charges. Okay, so let's go ahead and begin. Now remember, if a number doubles, we replace it with the factor of 2. If it triples, we will replace the variable with a factor of 3. If it quadruples, we replace the factor with the variable with a factor of 4. If something cuts in half, we replace it with half. If a variable does not change, then we replace the variable with the number 1. Okay, let's go ahead and take a look at practice 1. What happens, and I'm going to write the proportion up above. So F is proportional to Q1 times Q2 divided by R squared. So number 1, what happens to the force between two charges if the distance between them is triple? Well, notice the only thing that changes is the distance. The charges do not. So F would be proportional to charge 1 times charge 2. Both charges stay the same. So I'm going to put a number 1 for both charges. But the distance is tripled. So I'm going to replace R with the number 3, which is symbolic for tripling. Don't forget to square the distance. On the top, 1 times 1 is 1. On the bottom, 3 squared would be 3 times 3, or 9. The force is 1/9. Force is 1/9 as large, or you could say it's 9 times smaller. In other words, the force decreased because of the increase in distance. Number 2, what happens to the force between charges if the distance is quadrupled? So again, the charges did not change. So I'm going to put a 1 in for both, but I'm going to put a 4 in for R this time because quadruple means 4 times larger. And you'll notice that I get a proportion, a force factor of 1/16. What does that mean? The force is 1/16 as large, or you could say that it is 16 times smaller. In other words, the force decreased by 16 times, by a factor of 16. Okay, we'll go ahead and sort of highlight where we are at the moment. Okay, number 3, what happens to the force between two charges if the distance is cut in half? So F is proportional to 1 times 1, because again, the charges do not change, but the distance between them is cut in half. So I'm going to put R, replace R with a half, and don't forget to square that. Well, 1 times 1 is 1, and 1/2 squared is 1/4. Now, when I take 1 divided by 1/4, that's the same thing as multiplying by 4. That would be 1/1 times 4/1, which is really 4. I get a value of 4. So what does that mean? It means the force is quadrupled. It's 4 times larger. The force is 4 times larger than it used to be by cutting the distance in half. Number 4, what happens to the force between two charges if one charge is doubled? So F is proportional to, I'll double the first charge, then add the second, and the distance remains the same. So this would be 2 times 1 is 2 over 1 squared is 1, and I get an answer of 2. Okay, what does that answer mean? It means the force is doubled. Okay, or you could say it's 2 times larger. Number 5, what happens to the force between two charges if the magnitude of both charges is doubled? Okay, so now I'm going to replace both charges with a 2. The distance has not changed, so we'll replace R with a 1. And 2 times 2 is 4/1, which is 4. Which means the force is quadrupled. Or you could say the force is 4 times bigger. All right, number 6. What happens to the force between two charges if both charges double and the distance between them is doubled? So everything doubles. So F is proportional to 2 times 2 over 2 squared. Well, 2 times 2 is 4, 2 squared is 4, and we get an answer of 1. What does this mean? This force factor of 1 tells you that the force stays the same. It does not change. The force does not increase nor decrease. Number 7, what happens to the magnitude between two charges, the magnitude of the force between charges, if both charges are doubled and the distance cuts in half? So F is proportional to 2 times 2 on top, but we cut the distance in half. So replace R with a half and then square it. 2 times 2 is 4. A half squared is 1/4. Remember what we did earlier. When you divide by 1/4, you really multiply by 4. So this would be 4/1 times 4/1 is actually 16. Okay, what this means, of course, is the force is 16 times larger. Now, in part 2, we're actually going to put in charges into the Coulomb's law equation. So a couple things extra here that are not needed. F is equal to K times Q1 times Q2 divided by R, and then we need to square R. So we're going to be using the full equation this time, and you'll be using the full equation when you see actual charges and a distance separating those charges. So when you see that particular information, we're going to use the full Coulomb's law equation, not the proportional reasoning version of it. Practice 2, number 1. Two particles, each with a charge of 1 Coulomb, are separated by a distance of 1 meter. What is the force between the two particles? So what we're going to do is we're going to, let's see, we're looking for force. So F is the question mark. Okay. Anything that ends in coulombs is charge. So each with a charge, that means Q1 and Q2 are both 1 Coulomb. And we're separated by 1 meter, that would be R. So K, we always have to list K. K is 9 times 10 to the 9. Charge 1 and charge 2 are both 1 Coulomb. The distance R is 1 meter. The equation we're working with is K times Q1 times Q2 over R squared. Since we're looking for F and F is already isolated, go ahead and just start plugging in. Open parentheses, 9 times 10 to the 9 times 1 Coulomb times another 1 Coulomb. So times charge 1 times charge 2. Then close the parentheses, divided by open parentheses. Well, R is your 1 meter, close parentheses, squared. Take a second to put that in your calculator, and let's come up with the solution. Calculator. Okay, we're going to put in open parentheses, 9 times 10 to the 9, so 9 times 10 to the 9, times charge 1, which was 1 Coulomb, times charge 1, which is 1 Coulomb, close parentheses, divide, open parentheses again to now put the R. The R, the distance between the charges, was 1 meter, close parentheses, and then we got to square the R. So x squared equals, and we get 9 billion. Now, if you move the decimal from the far right to after the 9, you can see that it would be 9 times 10 to the 9 newtons for number 1. Number 2. What is the force between a 3 Coulomb charge, a 2 Coulomb charge, separated by a distance of 5 meters? Okay, let's go ahead and put this in. Let's annotate. So we know that the first charge, there's Q1. We know there's Q2. And we're separating this by 5 meters. Okay, go ahead and pause the video for a second and fill out your table. Okay, so you should have filled out F equals question mark. You should have filled out K for 9 times 10 to the 9. We're always given that. You should have filled out Q1 as 3 coulombs. You should have filled out Q2 as 2 coulombs. And finally, R is 5 meters. The equation you should have written was K Q1 Q2 over R squared. Since you are solving for F, just go ahead and begin substituting. And it's going to be open parentheses, 9 times 10 to the 9, times charge 1, which would be 3 coulombs, times charge 2, which would be 2 coulombs, close parentheses, divide, open parentheses, the distance between the charges would be 5 meters, close parentheses, and then hit your square button. Let's put that in our calculator. Open parentheses, 9 times 10 to the 9 times 3 coulombs, that's the first charge, times 2 coulombs, that's the second charge, close parentheses, divide, open parentheses again for the R that separates the 2 charges. The distance was 5 meters, close parentheses, and square. Okay, we get a pretty big number. We get 2,160,000,000. Moving the decimal from the far right all the way in between the 2 and the 1, okay, we get 2.16 times 10 to the 9th power. Again, why the 9th power? Because you had to move the decimal 9 times to get it between the 2 and the 1. Okay, number 3. Calculate the force between a 0.006 Coulomb charge, that's charge 1, and a 0.001 Coulomb charge, that would be charge 2, separated by 4 meters. You're again looking for force. You're given K, 9 times 10 to the 9. You're given Q1, 0.006 coulombs. You're given Q2, 0.001 coulombs. And you're given R, which is 4 meters. Your Coulomb's law equation, K Q1 Q2 over R squared. Begin substituting since we're already solved for F. It's 9 times 10 to the 9 times 0.006 times 0.001. All divided by, open parentheses, 4 meters, close parentheses, square. Okay, let's go to our calculator. We are going to go open parentheses, 9 times 10 to the 9 times the first charge, 0.006, times the second charge, 0.001, close the parentheses, divide, open parentheses again, your distance between the charges was 4, close parentheses, and hit your squared button, and we get about 3,375 newtons. Again, please remember to practice putting this in your calculator so that you can do this independently as well. Number 4, calculate the force between a 0.05 Coulomb charge, a 0.03 Coulomb charge, 2 meters apart. Well, there's Q1, there's Q2, and there's our distance. Again, looking for force. Again, K is 9 times 10 to the 9. Q1 is 0.05 coulombs. Q2 is 0.03 coulombs. R is 2 meters. F is K times Q1 times Q2 divided by R squared. F would be 9 times 10 to the 9 times charge 1, 0.05, times charge 2, 0.03 coulombs, close parentheses, divided by, open parentheses, 2 meters apart, close parentheses, square. Put that in our calculator. Okay, let's begin. Open parentheses, 9 times 10 to the 9 times 0.05 times charge 2, 0.03, close parentheses, divide, open parentheses, 2, close parentheses, squared. And we're getting 3,375,000. Now the decimal is here, and we need to move it 6 times. 1, 2, 3, 4, 5, 6. So the proper way to answer this would be 3.375 times 10 to the 6th power. I'd be okay if you rounded that up to 3.4 or 3.38 actually. Question 5. Two particles are each given a charge of 5 times 10 to the negative 5 coulombs. What is the force between the charged particles if the distance between them is 2 meters? So this charge right here, if each charge, two particles each have that charge, this would be Q1 and Q2. There, of course, is R, and yes, again, we're looking for the force. So K is 9 times 10 to the 9. Charge 1, which equals charge 2, is 5 times 10 to the negative 5 coulombs. R is 2 meters. F equals K times Q1 times Q2 over R squared. Let's go ahead and substitute our information in there. K would be 9 times 10 to the 9 times charge 1, which is 5, times 10 to the negative 5, times charge 2, which is 5, times 10 to the negative 5. Close parentheses. We're going to divide that by open parentheses, 2 meters, close parentheses squared. Let's put that in our calculator. Open parentheses, 9 times 10 to the 9 times 5 times 10 to the negative 6, negative 5, times 5 times 10 to the negative 5, close parentheses, divide, open parentheses, 2 meters squared. And we get about 5.625, or we can just round it up to 5.6 newtons. Question number 6. The force between a pair of charges is 100 newtons. So this time we're given the force. If the distance between the charges is 0.01 meters, and one of the charges is 2 times 10 to the negative 10 coulombs, what is the strength of the other charge? So Q2 is now, the second charge is now our unknown. We're given K 9 times 10 to the 9. We're given Q1, 2 times 10 to the negative 10 coulombs. We're given the force of 100 newtons. And we're given R, the distance between them is 0.01 meters. Okay. Now we're going to start this problem with the original equation, KQ1, Q2 over R squared. And in the solutions box, I'm going to begin by writing down what the equation is. F, leave a little space, K times Q1 times Q2 over R squared. Now keep in mind, you are trying to get Q2 by itself, which means you need to multiply by the reciprocal of what you're trying to get rid of, which is KQ1 over R squared. So we're going to multiply both sides by the reciprocal, which is R squared over KQ1 on the right side, and R squared over KQ1 on the left side. You'll notice K cancels, Q1 cancels, and R squared cancels, and Q2 is by itself. So the equation we're going to be plugging into is Q2 is equal to FR squared over K times Q1. Let's plug into that. Q1, or Q2 rather, is equal to F is 100 newtons times R, which is 0.01. We need to square that. Then divided by, open parentheses, 9 times 10 to the 9 for K, times charge 1, which is 2 times 10 to the negative 10 power. Now, in putting this in the calculator, here's what you ought to do first. Okay, first, go ahead and square this part first. Square the 0.01 first. Then multiply by 100 and then hit equals. Then you can go ahead and divide, open parenthesis, by the rest of what you see there. Okay, so let's go ahead and try that strategy. Let's go to our calculator. Okay, so I'm going to begin with the squared part first. So open parentheses, 0.01, close parentheses. Oh, no, sorry, not export. Let me clear that. Open parentheses, 0.01, close parentheses, squared times 100. That would be the whole numerator. And I'm going to hit equals to get a value on that. So that would be the total, the whole top part of the equation. And then divided by, open parentheses, 9 times 10 to the 9 times 2 times 10 to the negative 10. Close parentheses equals, we're getting a pretty small value for the other charge. So it's 0.00 and then a bunch of repeating 5s. So you can, so if we get, I'm sorry, what's that? If we get 0.0055 and then it's like a repeating decimal, that would be the same as, we got to move the decimal 3 times to the right. So it would be 5.6 times 10 to the negative 3 coulombs. Number 7, 2 equal charges separated by a distance of 1 meter experience a repulsive force of 1,000 newtons. What is the strength of each charge? So 2 equal charges means that Q1 equals Q2. We'll come back to that idea in a second. Distance of 1 meter, force of 1,000 newtons. Okay, now you're looking for Q. That's our question there. You're looking for the strength of each charge. We're given K as always. You're given the fact that R is 1 meter and you're given a force of 1,000 newtons. Okay, so I'm going to start with the main equation. F equals K Q1 Q2 over R squared. Please keep in mind, though, that if you have the same charge, if you have two equal charges, then Q1 and Q2, well, you don't need the 1 and the 2 anymore. It's just Q times Q, which would be Q squared. So I could just write it as KQ squared, which is Q times Q, over R squared. And we're going to solve that equation for Q. So we'll start here. F equals KQ squared. Sorry, let me fix that. F equals KQ squared over R squared. Okay, now keep in mind we are solving for Q. So you're going to have to get rid of the K over R squared and then the square root. Okay, that's the problem. So we can do that by multiplying by the reciprocal, which is R squared over K. Start there first. R squared over K, those cancel. And then you'll square root both sides to get rid of the square. And so we end up with R is equal to the square root of FR squared over K. And that's what we're plugging into. R, sorry, not R, T. I meant to say T. Let me fix that, my apologies. There we go. Q equals. So the charge equals the square root of, now we have 1,000 newtons times the distance is 1 squared, and then divide that by our K value, 9 times 10 to the 9. So here's our strategy. Here's how we're going to try and do this one. You're going to start by squaring this number times 1,000. Then we're going to hit equals, and we're going to divide it by 9 times 10 to the 9. And then we're going to go ahead and take the square root of that value. Let's go ahead and put this in our calculator. Okay, so I'm going to start with open parentheses, 1 squared times 1,000 equals, well, that'll be 1,000. Then I'm going to divide that by 9 times 10 to the 9. And then I'm going to hit equals again to divide those two. And then my last step is to take the square root of this information, square root of my answer, and I'm getting about 0.000 with 3 and repeating decimal. So 0.000, right? 3 coulombs, which would be the same as about 3.3 times 10 to the 1, 2, 3, 4, negative 4 coulombs. Number 8. The force between a pair of 0.001 Coulomb charges is 200 newtons. What is the distance between them? Okay, so pair of charges means Q1 equals Q2, and they both have that same value. The force is 200 newtons. You're looking for R. So R is the question mark. K is given. Q1 equals Q2, which is 0.001 coulombs, and the force is 200 newtons. Okay, we're using the main equation, F equals K Q1 Q2 over R squared. Now keep in mind, you're solving this equation for R. So to do that, you have to isolate the R squared first and then square root to get rid of the square. So let's start with F equals K Q1 Q2 divided by R squared. What we're going to do is we're going to switcheroo those two, swap them, and rewrite. And we get R squared equals K times Q1 times Q2 over, not R squared, over F. Okay, your last step would be to square root both sides. So R is equal to the square root of K Q1 Q2 over F. And that's what we're plugging into right now. R is equal to, we're going to go open parentheses, K is 9 times 10 to the 9, times Q1, which was 0.001, times Q2, which was also 0.001, close parentheses, divided by force, 2 newtons. Okay, let's take a second to put that in our calculator. We're going to go open parentheses, 9 times 10 to the 9 times 0.001 times 0.001, close parentheses, divided by 200. That would be everything under the radical, equals 45. Now we got to take the square root of 45. So square root answer, and we're looking at about 6.7 meters. Number 9. The force between two charges is 1,000 newtons. One charge has a value of 2 times 10 to the negative 5 coulombs, and the other charge is 5 times 10 to the negative 6 coulombs. What is the distance between them? So just like number 8, you're solving for distance. So we're given 9 times 10 to the 9. That's our value for K. We're given charge 1, we're given charge 2, and we're given the amount of force. So charge 1 was 2 times 10 to the negative 5 coulombs. Charge 2 was 5 times 10 to the negative 6 coulombs. The force was 1,000 newtons. F equals K Q1 Q2 over R squared. Again, you're going to begin by swapping out the R squared. So K Q1 over Q2 divided by R squared. So let's begin by swapping the F and the R squared. Rewrite it, and we get R squared is equal to K times Q1 times Q2 over F. Then we're going to go ahead and square root both sides. So R is equal to the square root of K times Q1 times Q2 divided by F. Let's plug into this. R is equal to, we're going to go 9 times 10 to the 9 times the first charge, which is 2 times 10 to the negative 5, times the second charge, 5 times 10 to the negative 6, close parentheses, open parentheses, divided by a force of 1,000 newtons. Okay, and then we'll take the square root of that once we're done. Let's go to our calculator. Okay, open parentheses, 9 times 10 to the 9, okay, times 2 times 10 to the negative 5, times 5 times 10 to the negative 6. close parentheses, divide by 1,000 equals 0.0009. Take the square root of that, and we're looking about 0.03 meters, or 3 centimeters, essentially. And finally, question number 10. The force between two charges is 2 newtons. The distance between two charges is 2 times 10 to the negative 4th power meters. If one charge is 3 times 10 to the negative 6 coulombs, what is the strength of the other charge? So we're looking for Q2. We're given K. Okay, we are given Q1 at 3 times 10 to the negative 6. We are given a force of 2 newtons. And we're given R of 2 times 10 to the negative 4 meters. We're using the equation K Q1 Q2 over R squared. Now, remember, guys, you have to solve this for Q2. Okay, so we'll start by writing the main equation. F, leave a little space, is equal to Q1 Q2 over R squared. Remember how we accomplished this last time. To solve for Q2, you have to get rid of everything else. So how do you get rid of everything else? You multiply by the reciprocal of everything else. The reciprocal of KQ1 over R squared would be R squared over KQ1. And we multiply that both sides. Cancels, 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 cancels. Q2 is by itself. So let's rewrite. And we get Q2 is equal to FR squared over K times Q1. Let's plug in for charge 2. Force is 2 newtons times the distance, which is 2 times 10 to the negative 4th power, and we have to square that. Divided by, open parentheses, and we're going to go K, 9 times 10 to the 9, times charge 1, which was 3 times 10 to the negative 6th power. Okay, here's the strategy how we're going to put this in our calculator. Let's first take this number and square it, then we're going to multiply that by 2. Then we'll go ahead and divide by what's on the bottom. All right, let's go ahead and try this. Okay, open parentheses, 2 times 10 to the negative 4, close parentheses, squared, times 2. That is the whole numerator of this equation that we're plugging into. I'm going to hit equals so I can multiply all that. And I get 8 times 10 to the 8th power so far. We're going to divide that by, open parentheses, 9 times 10 to the 9 times 3 times 10 to the negative 6. Close parentheses equals 2.96 times 10 to the negative 12. Very small charge. Very small charge. 2.96 times 10 to the negative 12 coulombs. Again, please practice putting these values into the calculator yourself so that you can have the confidence to do this work independently. I hope you found this video tutorial helpful.